This is chapter 2.1, exercises 19 through 26. This section of the book, 2.1, has to do with polynomial functions, and this piece has to do with graphing quadratic functions, and specifically from the vertex form. And I have this xy coordinate plane here to demonstrate the graph of the parent quadratic function, because that's going to be very useful. So if we have the function f of x equals x squared, the parent quadratic function, we can create a table. We have input of x, output of f of x, and our center value for this function will be 0. So if we let x equal 0, what is f of x? Well, we have is 0 squared is 0. Next, if we go to 1, input of 1, we have f of x equals 1 squared, which is 1. And then for negative 1 on the other side of the 0, we know that because of the symmetry of a parabola, we know the output for negative 1 is likewise going to be 1. And then if we have an input of 2, we have an output of 2 squared, which is 4. And at x equals negative 2, if we have negative 2 squared, that is also 4. And the last one we'll look at in this simple sketch is an input of 3. If we have an input of 3, 3 squared is 9. And then if we come over to the other side, we have input of negative 3 is also 9. So we have a certain symmetry, and we'll go ahead and quickly sketch these points. We have 0, 0, 1, 1, negative 1, 1, 2, 4, negative 2, 4, and 3, 9. Let's see, 4, 5, 6, 7, 8, 9. And we have negative 3, 9. And so we can just make a rough sketch here with these 7 points. And that's going to be very rough. But come here. So anyway, that's what the basic thing looks like. And there's a pattern here. If we take the point 1, 1, that's going to be a plus 1 from the origin. And then 4 is going to be a plus 3 from the 1. And then 9 is going to be a plus 5 from the input of 4. So 1, 3, 5. And on the other side, we also have plus 1, plus 3, plus 5. And it may not be clear right now. When we go through the exercises, it will be, and very useful. We're going to go back to this. Okay, problem 19. Well, exercise 19 to 22, describe how to transform the graph of f of x equals x squared in the graph of the given function. Sketch each graph by hand. Well, this goes back to what we've talked about in section 6.1, the graph of transformations. Which way does this shift or translate? Well, x minus 3, it's going to be translates right 3 units, and also translates down 2 units. So we have translates right. We're going to go over here to the coordinate plane. We go right 3 and down 2. So right here in red is the vertex, and the coordinate pair for that vertex is going to be 3 comma, -2. Write that a little more legibly if I can. 3, comma, -2. And we look at outside the, remember the standard form? You remember that's going to be, of a quadratic function is going to be a times 20x minus h squared plus k. Okay, so we're given vertex form. In this case, the a is 1. So I'm going to draw another quick little table like we did before this exercise. We have x, in this case g of x. In this case, we know that our starting point is at x equals 3. At x equals 3, our output is -2. And then we go back here, we have a is equal to 1, so we just have the plus 1 plus 3 plus 5, plus 1 plus 3 plus 5, and up above we have plus 1 plus 3 plus 5. So we have 3, and then we have point after 3, 4, 5, 6, and going to the left of 3 we have 2, 1, and our y-intercept is 0. And so we're starting out at a y value, output value of -2, and we add 1 to that, we get -1, and because we went up 1 on the left, on the right side, we go up 1 on the left. And next we add 3 to this to get to the next value, so we have -1 plus 3. -1 plus 3 is 2. And then we go to the other side for an output of 1. For input of 1, we have an output of 2. And next we add 5. Well, 2 plus 5 is 7. And then, so we come over to the other side of the parabola at our y-intercept, we have also 7. And if we multiply this out, if we take -3 squared, that's going to be 9, and 9 minus 2 would be 7. So that makes sense. So we can finish graphing our points. We have 4, -1. We have 2, -1. We have 5, 2. So that goes up here. And we have 1, 2. So that, oops, 1, 2 is up here. Excuse me, it's 5, 2. We have 1, 2 here. Then we have 6, 7. So 6 to the right, up, 1, 2, 3, 4, 5, 6, 7. And our y-intercept here. So that's what this graph looks like. Just make a little, doesn't have to be super accurate. You're going to have a little more dexterity probably on your graph than I have here with this glitchy pen. But you're just kind of looking to kind of go through the points. So that's our sketch. And our axis symmetry is going to be this one here. I'm sketching the dotted purple line. Axis symmetry is going to be x equals 3. So axis symmetry, x equals 3, our vertex 3, -2, and the sketch the graph starting point. So getting off the starting point, knowing A. Next on our problem, we have 21. Okay, again, the vertex form, we have, this in this case translates to the left, so we will say translates left 2 units, and also and down 3 units. That minus 3, that's the k. So we can find our vertex by going to the left 2 and down 3. So that's our vertex. Now, we're going to do our little table. We have x and we have h of x. And we know our coordinate pair for our vertex is going to be, as we mentioned, -2, comma, -3. So that's our coordinate pair for our vertex. Our axis of symmetry is going to be, here I'm making this one, x equals -2. That's our axis of symmetry. And our starting point in our table is going to be the vertex, which is -2, comma, -3. Now in this case we have our a is equal to 1/2. So if we go back to our little hand-drawn graph here, what that's going to do is change everything. Instead of this 1, we're going to have this being 1/2 or 0.5. The next one, instead of being 3, is going to be 1/2 of 3 or 1.5. And the last step, instead of being 5, we can take 5 divided by 2 or 2.5. So that's going to change how we look at things. So come back to the table here. And if we go to the next one up, we have -1. Well, instead of adding 1, we add 0.5, we will call that. So we have -3 plus 0.5 is going to be -2.5. And if we come over to the left, which is going to be -3, we're also going to have -2.5 as an output. And so next, if we go to if we go to 0, x equals 0, we're going to add, instead of 0.5, we're going to add 1.5. So -2.5 plus 1.5 is going to be -1. And then if we come over here to the other side for an input of -4, we're also, because of symmetry, going to get an output of -1. And then if we go to the next value, input value, which is 1, going up one value more, we're going to add 2.5, which is half of 5. So -1 plus 2.5, that's 1.5. And coming over to the other side, where x equals -5, we have an output also of 1.5. So now we're ready to continue our sketch. We have 2, comma, -2, comma, -3. Next one we have is, if we go up, we go to -1, comma, -2.5. So here's -1, comma, -2.5. And on the other side, we have -3, comma, -2.5. And next one we have is 0, comma, -1. And the other side we have -4, comma, -1. And then the right side at x equals 1, we have an output of 1.5. And then for input of -5, we have an output also of 1.5. And so what we have here is we have a shallower parabola that's opening up wider. And we could say this is compressed vertically or stretched horizontally. That's going to be our graph. Next, let's go to the next algebra problem, which is 23. Find the vertex and the axis of the graph of the function. Well, to find the vertex, the a doesn't matter at all. So we have translates one unit I'll say 1 unit. To the right, and 5 units upward, this k plus k, and 5 units upward. I'll just say up. And so we will say our vertex for this is going to be the point 1, 5. And as far as it says axis of the graph, we'll say axis of symmetry we will say x equals 1. And so these would be our answers for problem number 23. Our last problem in the set we're going to be looking at is this one here. Well, in this one, the A doesn't make any difference as far as where the vertex and the axis are. So we will say translates minus k, it's x minus h. And so since h is 1, we will translate 1 unit to the right and 7 units down. K is -7. So for this one, we're going to have our vertex at the point 1, -7, and our axis of symmetry is going to be the equation x equals 1. So that's going to be our odd number problems in this set. Good luck in these even number problems, a demonstration of learning. This one here, on 26, you have a square root here. Well, it's just going to move this, I think, square root of 3 to the right. Okay, thanks for viewing and good luck.